These are slides 18A. We're going to start with slide number 22, which is an image of the exterior of the heart. And you can see in this image, you can see the right atrium really clearly, a little portion of the left atrium, then the right ventricle, the interventricular septum, the outer portion of it, which has fat in between and blood vessels running in between. And then you can see a portion of the left ventricle, although more of the left ventricle is shown on the posterior side of the heart. You can also see clearly the pulmonary trunk and the aorta, some branches of the aorta, the brachiocephalic trunk, the left common carotid artery, and the left subclavian artery. You can see the pulmonary veins, the left pulmonary veins and the right pulmonary veins. You can see the oh gosh. See, this is the interventricular septum here, and then the atrioventricular septum. I had to think. Okay, so inferior vena cava, superior vena cava. And then some of the blood vessels, the major blood vessels I want to point out that supply the heart muscle itself. Let's look at the right coronary artery, which is in the coronary sulcus here. The left coronary artery, the circumflex artery, the left coronary artery, and the circumflex artery. Then we have the anterior interventricular artery that runs through the interventricular septum. We have the great cardiac vein. And over here we have the anterior cardiac vein. The right marginal artery branches off of the right coronary artery. Then we have the small cardiac vein. So these are just the blood vessels, the coronary arteries and veins that you can see on the anterior surface of the heart. And then I wanted to point out the ligamentum arteriosum, which connects the pulmonary trunk to the aorta, kind of holds them together. This is the posterior view of the heart. You can see the great cardiac vein a lot better, and you can see this bulge in the great cardiac vein is called the coronary sinus, which is where the blood returning to the right atrium from the heart, from the coronary circulation, that's where it collects before it returns to the right atrium. Let's see, middle cardiac vein, the posterior interventricular artery, the right coronary artery, see if there's anything else. Posterior vein of the left ventricle. We already said the great cardiac vein and the cardiac sinus, or the coronary sinus. Okay, I think we've named them all. Okay, so the receiving chambers of the heart are called the atria. The appendages of the atria that look a little bit like elephant ears are called auricles, and they increase the volume of the atria. The right atrium receives oxygen-poor blood from the body. The posterior portion of the right atrium, lining kind of the posterior wall, is formed by pectinate muscles. There are 3 veins that empty into the right atrium, and they are the inferior and superior vena cava and the coronary sinus. And then the left atrium has its own pectinate muscles. and it receives oxygen-rich blood from the lungs. I think we already went through this one, pretty sure. Just let me make sure. Yeah, okay. I didn't know it was in here twice. But the pectinate muscles, I'll point out. Yeah, pectinate muscles. You see how they are? They're kind of like along the back wall, and you have them in the left atrium too. The ventricles are the pumping chambers of the heart. The right ventricle makes up most of the anterior or front surface of the heart, and the left ventricle makes up the back of the heart mostly, but it is the largest of the two ventricles. The trabeculae carneae are irregular ridges of muscle on the ventricular walls, and papillary muscles anchor the chordae tendineae or heartstrings that hold the heart valves that attach to the heart valves. The ventricles are the pumps of the heart. The right ventricle pumps blood into the pulmonary trunk so that it can take that blood to the lungs. The left ventricle pumps blood into the aorta, which is the largest artery in the body. And you can see here the papillary muscles connected to the chordae tendineae. The trabeculae carneae are the muscular ridges in the walls of the ventricles. So trabeculae carneae form those muscular ridges. The papillary muscles attach to the chordae tendineae, which attach to the AV valves. This one is the tricuspid valve, and then this one is the mitral or the bicuspid valve. And this is just an image from an actual human heart where you can see the pectinate muscles of the atrium. And you can see the papillary muscles, the trabeculae carneae, the chordae tendineae, which are the heartstrings that attach to the tricuspid valve here, which is found between the right atrium and the right ventricle. You can watch this animation. This comes from, just to let you know, it comes from slide number 32. I can't show animations during the slideshow for at least with the recording app that I use, which is oh gosh, ScreenPal, called ScreenPal. Anyway, here you can see the aorta is very, very thick and muscular because it's under such a great deal of pressure. You can see the pulmonary trunk very clearly. Now again, there's another animation, and now we're on to section 2, 18.2, which is on the heart valves. And what they do is they ensure that blood does not flow back into the atria from the ventricles. There are 2 AV valves and 2 semilunar valves. The AV valves are the tricuspid and bicuspid or mitral valves. And then the you can see them here. You can see them closed. And the chordae tendineae or heartstrings anchor the AV valves to the papillary muscles. The purpose of the AV valves is to prevent the backflow of blood into the atria from the ventricles. Here's a very good illustration of an AV valve. I don't think it, well, yeah, it does. It shows you this is the bicuspid because it has 2 cusps. The bicuspid or mitral valve, and this is closed. The mitral valve closed and the mitral valve open. And then you have your semilunar valves because the cusp, the valves look like half moon shapes. The aortic valve prevents blood from flowing back into the ventricle, the left ventricle from the aorta, and the pulmonary valve prevents the backflow of blood into the right ventricle from the pulmonary trunk. This is the location of the pulmonary valve. So you can see the pulmonary valves open and the pulmonary valve close, pulmonary semilunar valve. Two conditions that severely weaken the heart are incompetent valves, and in that case, some blood flows back past the valves. And valvular stenosis is from stiff flaps that constrict the opening, so the heart has to work harder to pump the blood. A defective valve can be replaced with a mechanical, animal, or cadaver valve. I've definitely heard of pig valves. Now, this is the pathway of blood flow through the heart. If we start with the vena cava, the superior vena cava returns blood to the heart from the upper body. The inferior vena cava returns blood to the heart from the lower body, and the coronary sinus returns blood to the heart from the heart blood vessels that supply the heart, the coronary circulation. And all of that blood returning to the heart enters the right atrium, passes through the tricuspid valve into the right ventricle, passes through the pulmonary valve into the pulmonary trunk. Pulmonary trunk branches into the pulmonary arteries. The blood is taken to the lungs where it picks up oxygen. Then it returns to the left side of the heart through the pulmonary veins into the left atrium, past the mitral valve or bicuspid valve into the left ventricle, and then through the aortic valve into the aorta, and then through arteries and capillaries to the systemic circulation or the body systems. And here is the pathway, showing you the pathway of blood flow, a figure showing you the pathway of blood flow. A comparison of the ventricles, the left ventricle walls are 3 times thicker than the right because the left ventricle has to pump blood so much farther. The right ventricle only has to pump blood to its left and right. And now you can see a cross section. Here are the walls of the left ventricle compared to the walls of the right ventricle. The coronary circulation is the functional blood supply to the heart muscle itself. It is delivered when the heart is relaxed, and the left ventricle receives most of the coronary blood supply because, of course, it needs it more. It's a thicker muscle. The left and right coronary arteries arise from the base of the aorta. Both encircle the heart in the coronary sulcus, and the arteries contain many bypasses. I always call them bypasses or anastomoses. These provide additional routes for blood delivery, but they cannot compensate for coronary artery occlusion or blockage. Because coronary arteries are the main ones. So if they're blocked, I mean, that's bad. That's really bad. Really, really bad. The left coronary artery supplies the interventricular septum, the anterior ventricular walls, the left atrium, the posterior wall of the left ventricle, and it has 2 branches, the anterior interventricular artery and the circumflex artery. Then you have the right coronary artery that branches into the right marginal artery and the posterior interventricular artery. So looking at the major arteries, we have the left coronary artery branches into the circumflex artery and the anterior interventricular artery. Then we have the right coronary artery that has branches called the right marginal artery and the posterior interventricular artery. See how that branch runs along the back, the posterior side. Then we have the coronary veins, the cardiac veins, the coronary sinus. And then there's the great cardiac vein, the middle cardiac vein, the small cardiac vein, and then several other anterior cardiac veins. So we can see here the big bulge in the great cardiac vein called the coronary sinus. We can see the anterior cardiac veins, the small cardiac vein, and the middle cardiac vein. Okay, again, we can see in a view of the heart, we can see the great cardiac vein and then the coronary sinus. The middle cardiac vein here, and we can see the right coronary artery, and we can see the posterior interventricular artery, and we can see circumflex artery, although I don't think it's labeled. Anyway, heart conditions, angina pectoris is chest pain, and it's caused when you hear somebody say they're having angina. They're having chest pain caused by a fleeting deficiency in blood delivery to the myocardium or the heart muscle. And during angina pectoris, heart muscle cells are weakened. But the word for heart attack is myocardial infarction, which literally means cardio for heart, myo for muscle, infarction for death, heart muscle death. And that is prolonged coronary blockage, and areas of cell death are repaired with non-contractile scar tissue. We're going to go on into section 18.4 next, cardiac muscle fibers.